Every skyscraper, every massive cathedral, and every sprawling museum you've ever walked into, well, it began with a deliberate act of destruction.
That is a pretty dramatic way to put it.
I mean, it's true though, right?
Right.
Architects literally have to flatten a three-dimensional reality into a strictly two-dimensional illusion.
They absolutely do. It serves as the absolute bedrock of spatial communication.
Our mission today is to uncover the secret, invisible language that makes those spaces possible. The language architects use to translate the complex physical world onto flat pieces of paper.
Yeah, because we often think of architecture as a purely immersive sensory experience,
Right, like you walk into a room, you feel the height of the ceiling, you see the light hitting the floor.
Exactly. But long before anyone can feel a space, the architect has to encode that future reality into a highly precise, deeply structured matrix of flat drawings.
And we are pulling our insights today from a truly foundational text called Plans, Sections, Elevations, Communicating Space Through Orthographic Drawing.
It is a classic for a reason.
It really is. And if you're listening to this and wondering why you should care about how architects draw, think about the last time you stared at a floor plan for a new apartment and felt just completely lost.
Oh yeah, like trying to read an alien language.
Right. Or maybe you walked past a massive skyscraper under construction and wondered how something so gigantic and honestly dangerous goes from a computer screen to a real-life structure without, collapsing.
It is a small miracle every time.
It is. So by the end of this deep dive, you're going to have the X-ray vision required to read spaces just like an architect does. Okay, let's unpack this.
Let's do it.
Before we get into the specific types of drawings, we first have to talk about why architects actively avoid drawing things the way the human eye actually sees them.
Yes, this is huge.
We were talking about abandoning perspective entirely, right?
That deliberate shift is the defining hurdle of architectural thinking. I mean, a standard perspective drawing mimics human vision. It relies on vanishing points, atmospheric depth, and the subjective reality of standing in one specific spot.
So it looks exactly like a photograph.
Exactly. It's highly emotional and clients love it, but it's completely useless if you need to, say, measure a beam or align a concrete foundation.
Because the perspective warps the real sizes.
Precisely. So architects replace that subjectivity with what we call orthographic drawing.
Orthographic.
Yeah. This is a method where a three-dimensional object is projected onto a two-dimensional plane using parallel lines. The crucial mechanism here is that those lines remain entirely perpendicular to the drawing surface.
So wait, you're projecting the image straight on, effectively stripping away all the optical distortion.
Every bit of it.
Nothing shrinks in the distance. Like a window that is 50 feet away from you is drawn at the exact same scale as a window that is 5 feet away from you.
That's right. The distortion of the human eye is entirely removed. And because of that consistent scale, you can read dimensions directly off the page with a ruler.
Oh.
Yeah, the spatial relationships between the different parts of a building aren't warped by your vantage point. It turns subjective experience into a measurable, objective fact.
But, I have to push back on this a little bit.
Okay, go for it.
If perspective is how we actually experience the world, like this rich, atmospheric, lived experience, then orthographic drawing is more like a rational, cold MRI scan of a building.
That's a good way to put it.
You wouldn't take a picture of a patient's face to see if their femur is broken.
Right.
You take an X-ray. But in architecture, isn't removing the lived experience of depth and vanishing points a massive disadvantage?
How so?
Well, you're losing the very human element you are supposedly designing for.
What's fascinating here is that this abstraction is exactly its superpower.
Really?
Yes. By aggressively removing all the visual complexity that perspective introduces, the architect gains surgical focus. They can isolate specific systems, they can analyze just the horizontal organization or strictly the vertical load-bearing relationships without the distraction of how the lighting looks from the sidewalk. It is a tool for diagnostic clarity.
So by flattening it out, they can actually manipulate the structure more rigorously.
Exactly. A building is far too complex to solve all at once.
That makes sense.
Yeah.
And the text notes 3 principal orthographic views that architects use to perform this surgery.
Sure.
The plan, the section, and the elevation.
The holy trinity of architectural drawing.
Right. And we should make it clear to everyone, these aren't different versions of a building. Each one is a different imaginary cut or projection of the exact same geometry.
Right. None of them can build the building alone. They form a totally interdependent system.
So let's grab our imaginary scalpel and make the very first cut. We are slicing the building horizontally to see how light flows through it. Let's talk about the plan.
The plan is arguably the primary engine of architectural thought. It is a horizontal orthographic projection. The convention is to imagine a horizontal cut slicing through the entire building, usually right around the height of a window or a door head.
So like about 4 feet off the floor?
Roughly, yeah.
So you slice the building horizontally, lift the entire roof and the top half off, throw it away, and look straight down at the severed walls.
That specific downward gaze reveals the architecture of arrangement.
Right.
You see room adjacency, you see circulation routes, meaning the exact path a human body takes to navigate the space. You see zoning, thresholds, and the physical thickness of the walls.
But reading it requires understanding the graphic mechanics, right? Because it's not just a drone photograph looking down into a roofless house.
No, not at all. An architect uses line weights to trick the viewer's brain into understanding what is solid and what is void.
Line weight is everything in this.
It really is. The elements that are actively sliced through by that imaginary horizontal knife like the masonry walls or the steel columns, they are drawn with heavy, dark, aggressive lines.
Oh, I've seen that.
Yeah, sometimes they are even filled in with solid black ink, which is a technique called poche.
Poche.
Right. Meanwhile, elements that sit below the cut line, like the sill of the window or the pattern of the floor tiles, those are drawn with whisper-thin, lighter lines.
So this visual hierarchy immediately signals to the builder, hey, this thick line is impenetrable mass and this thin line is open space.
Exactly. You are communicating mass and void without using 3D rendering.
You know, the source material mentions that architecture students spend semesters doing nothing but redrawing plans from famous precedent projects.
Oh, countless hours.
They literally trace over the exact floor plans of historical buildings just to uncover the hidden logic.
It is an exercise in reverse engineering genius.
What are they looking for, exactly?
They are looking for proportional systems or spatial hierarchies that are completely invisible when you just walk through the front door. The plan is the ultimate design generator.
Okay.
It's where an architect tests the functional logic of a society. Think about a public library, for example. The plan is the tool that establishes the behavioral gradients. How do you transition a patron from a loud, bustling entry lobby through a transitionary gallery, and finally into an intimately scaled, dead silent study zone?
So the plan actively dictates human behavior.
It orchestrates it, yeah.
I see the power of that, but I have to point out the fundamental weirdness of this entire perspective.
What do you mean?
Humans do not float 4 feet above buildings looking downward through severed walls.
Right.
We never, ever experience a building this way.
That is very true.
So I have to challenge the supremacy of the plan here. Does a geometrically perfect, beautiful plan actually guarantee a beautiful building?
That is the quintessential trap of architectural education.
Really?
Yes, and the source text warns against this heavily. A plan can look like a masterpiece of geometric balance on paper. You know, perfect symmetry, elegant interlocking shapes.
Sounds great on paper.
Exactly, on paper. But it can fail completely when a human body actually tries to occupy it.
Oh, wow.
Yeah, a star-shaped plan might look stunning from a bird's eye view, but navigating the resulting sharp, acute angles on the inside could feel incredibly claustrophobic and aggressive.
I never thought about that.
The logic of the plan cannot be mistaken for the whole of the architecture.
Because the plan handles the horizontal flow, it completely suppresses height. It's basically a massive blind spot.
It is.
We need a totally new tool to understand how a space actually feels vertically. Like, is the ceiling going to crush me, or is it soaring up to the heavens?
Exactly.
This requires changing the direction of our imaginary knife.
We rotate the scalpel 90 degrees. We move from the horizontal cut to the vertical cut. This is the section.
So instead of slicing parallel to the floor, we are slicing straight down from the sky, right?
Yep.
Cutting through the roof of the floors, straight down into the dirt of the foundation. Then we pull away one half of the entire building and look directly at the exposed raw edge.
The section reveals the interior vertical dimension. It shows floor-to-floor heights, the complex volumes of the ceilings, and how different levels interlock.
Yeah.
Crucially, it exposes the path of natural light. You can see how a sunbeam enters from a skylight and penetrates down through 3 different floors.
It fundamentally reminds me of slicing an ant farm down the middle.
Oh, I love that comparison.
Yeah, when you look at an ant farm from the side, you see the complex vertical tunnels. You see how the ramps connect the upper chambers to the lower ones, and how the entire ecosystem stacks up from the deep dirt at the bottom all the way to the surface.
The ant farm analogy is perfect because it illustrates the interlocking nature of space. Just like those tunnels, the section reveals the structural reality, bridging the imagination with the buildable world.
Right.
You literally see the deep concrete footings in the earth, the floor joists spanning the rooms, all the way up to the insulation in the roof assembly.
The text provides some brilliant examples of buildings that simply cannot be understood without a section drawing. It mentions a house stepping down a steep rocky hill.
Yes.
If you look at that house in a floor plan, you just see a bunch of overlapping rectangles and maybe some staircases. It looks completely flat.
It tells you nothing about the terrain.
Exactly. But the section reveals the vertical cascade. It shows how the living room drops dramatically into the hillside to create a cavernous space, while the bedroom cantilevers, like just hovering in the tree.
Or consider the example of a church defined by a massive vertical lake shaft.
Oh, right.
In a floor plan, that architectural feature is just a circle drawn in the middle of the room. It conveys zero emotional weight.
It's just a circle.
Right. But in a section, you see a 60-foot funnel of divine atmospheric light piercing the darkness and hitting the altar. You see architecture as sheer volume.
The text also mentions a library organized around a giant central void. A floor plan just shows a blank, empty square in the middle of the reading room.
Which looks like wasted square footage from above.
Literally just empty space. But the section reveals a breathtaking multi-story atrium where the balconies of every floor overlook one another. It creates this shared acoustic and visual community.
The section is the drawing of compression and release.
Yeah.
It illustrates the physical sensation of walking through a low, tight corridor and suddenly emerging into a towering, luminous hall. You just cannot draw that sensation in a plan.
You need the section.
But it's worth noting that architecture students typically struggle far more with sections than they do with plans.
Why is that? Is it just the mental gymnastics of the ant farm complexity?
It requires a relentless amount of three-dimensional imagination.
Oh, I bet.
When you draw a plan, you are mostly mapping where objects sit on the ground. To draw a section, you have to mentally track not only where spaces are, but how they rise, how they connect vertically, and crucially, what sits in the background beyond the plane of your imaginary knife.
Oh, right, because you're looking into the room.
Exactly. You have to understand the entire three-dimensional puzzle simultaneously.
So we've mastered the interior logic with the plan, and we've mastered the vertical volume with the section. But we still have a massive blind spot here.
We do.
Neither of these drawings tells a builder how the building confronts the outside world. Buildings aren't invisible ant farms. They actually face a city street.
Which means we need the third orthographic projection, the elevation.
The elevation is a drawing of one exterior vertical face of a building viewed straight on. No cuts this time, right? We put the scalpel away.
No scalpels needed. We are just looking at the outside skin.
Just the skin.
It portrays the exterior appearance entirely without perspective distortion.
So it gives us the proportion of the windows, the rhythm of the structural columns, the silhouette of the roofline against the sky, and exactly how the heavy mass of the building anchors into the ground.
The elevation is the tool for urban context. Buildings participate in a civic dialogue.
Great, they don't exist in a vacuum.
Exactly. They sit on streets, they border public squares, they react to landscapes. The elevation is where the architect studies how their building responds to its neighbors.
Does the cornice line of this new modern museum respect the historical rhythm of the brick buildings next door, or does it intentionally disrupt the streetscape?
That's the exact conversation an elevation facilitates.
Here's where it gets really interesting. Because orthographic drawing strictly flattens depth, the elevation presents a unique mechanical problem.
Oh, massive problem.
A window that is recessed 3 feet deep into a thick stone wall looks just as flat on a piece of paper as a cheap glass window sitting perfectly flush with the siding.
Yep.
So how does the architect fake that depth without using perspective? Does the drawing just become a cluttered mess of lines trying to explain the facade?
This is where the sheer graphic restraint of the architect is tested. Because you cannot rely on vanishing points, a successful elevation relies entirely on line hierarchy to trick the brain.
Just like the plan.
Just like the plan. By using a thick, heavy black line for the outer contour of the building, the architect visually pops the entire structure forward.
Okay.
And by using whisper-thin, delicate gray lines for the recessed window frames, they push those elements into the background. They might apply light, mathematically calculated shadowing to prove the window is deeply recessed.
Shadowing without perspective.
Right. Or they use subtle tonal differences to explain that one wall is heavy concrete while another is light reflective glass.
So you're basically mathematically recreating depth.
Yes. It is the building's public face. Plans organize our lives, sections shape our spatial experience, but elevations are fiercely compositional.
Right.
They represent the building's cultural and civic contribution to the public realm.
Okay, so we now have three entirely different, highly abstract views of a single object. We have the plan, the section, and the elevation.
Your complete set.
How does an architect ensure that these three flat illusions don't completely contradict each other when the concrete is actually poured?
Well, none of these drawings function in isolation. The plan shows arrangement, but ignores height.
Right.
The section shows height, but sacrifices the full horizontal spread. And the elevation shows the public face, but hides the interior guts.
They need each other to triangulate reality.
Exactly. A window drawn on the outside in the elevation must align perfectly with the internal light shaft shown in the section, and its placement must land perfectly within the room arrangement mapped in the plan.
It has to be flawless across all three.
Yes. Coordinating these translations, ensuring the logic holds up across all three dimensions simultaneously, that is the core discipline of the profession.
And the text highlights that this matrix of coordination isn't just for the architect's ego. These drawings serve a massive conflicting audience.
Oh, totally.
You have the clients paying for the building who want to see the layout. You have the structural engineers calculating the steel loads based on the section. You have the builders on site pouring the foundation, and then the city planning authorities checking the elevation against zoning laws.
That's a lot of cooks in the kitchen.
Yeah, and they all rely on this shared measurable matrix.
Orthographic drawings provide a common legal and technical basis for execution. They transition architecture from a vague artistic impression into a reasoned, coordinated, legally binding reality.
But let's bring this into the reality of the digital age. Architects aren't hunched over wooden drafting tables with T-squares and graphite anymore, are they?
Mostly no.
They're using CAD computer-aided design and incredibly complex BIM platforms, building information modeling like Revit or Rhino.
The standard of the industry now.
Right. And these software platforms allow the architect to build a flawless, perfect 3D digital model. Then, with the click of a mouse, the software automatically generates the horizontal and vertical cuts.
Instantly.
So with the machine doing all the heavy lifting, aren't traditional two-dimensional flat drawings fundamentally obsolete?
This raises an important question because it touches on a massive friction point in modern architectural education.
Okay.
The medium has undeniably shifted, but the cognitive discipline of the drawing remains identical.
Walk me through that. If the computer does the cutting mathematically perfectly, what is left for the architect to do?
The software generates data, not communication. If you tell a BIM program to slice a section through a massive hospital, the machine will spit out a completely literal, mathematically perfect slice that includes 10,000 lines of chaotic data.
Oh, wow.
It will show every single screw, every cross-section of every HVAC duct, every wire conduit in the ceiling plenum. It is visually unreadable to a human builder trying to frame a wall.
It's just a wall of noise.
Exactly the problem. The software automates the geometry, but the architect must actively curate the information.
I see.
The architect has to look at that automated chaos and decide what to suppress and what to emphasize. They have to thicken the concrete wall lines and hide the ductwork lines to establish hierarchy.
So they still have to apply the line weights manually, essentially.
Mentally, yes. If an architect lacks the traditional literacy of orthographic drawing, they are merely using the software as an expensive printer. They aren't telling a spatial story, they're just dumping data onto a page.
The curation is the architecture.
Beautifully said.
Which brings us to a critical final piece of this puzzle. If orthographic drawing is this highly precise, heavily automated, deeply abstract diagnostic tool, how do we prevent the final product from feeling like a sterile, cold geometric diagram?
The ultimate danger of abstraction is forgetting the human scale. A drawing can be mathematically flawless, but if you don't know the size of a human body in relation to those lines, the space is cognitively meaningless.
The source material offers a brilliant illustration of this. It points out that the difference between a room that is 2.4 meters tall and a grand hall that is 6 meters tall is practically indistinguishable on a flat piece of paper.
Until you draw a person?
Exactly. Until you draw a tiny, accurately scaled human figure standing inside it. The moment you place that figure, the 2.4 meter room suddenly reads as intimate, maybe even uncomfortably tight, while the 6 meter hall instantly registers as monumental and soaring.
The inclusion of scale figures is non-negotiable, and it extends beyond people too. A readable drawing must include contextual markers.
Like what?
Well, furniture layouts in the plan to prove a living room actually functions, light fixtures in the section to show atmosphere, cars on the street, and mature trees in the elevation to anchor the building to the neighborhood.
So when you see an architectural drawing featuring a beautifully sketched oak tree or the ghostly silhouette of a person reading a book on a bench, it's not just an artistic flourish to make the client smile.
Not at all.
They're anchoring the abstract mathematics back to physical reality.
If we connect this to the bigger picture, orthographic drawing only succeeds when it humbles itself to remember that architecture is ultimately built for human occupation. All the intense visual hierarchy we've discussed, the heavy line weights, the poche, the shading, it all exists purely to make technical data readable to the human eye.
So what does this all mean? Let's trace the mechanics of our journey. We started by deliberately destroying the distortion of our own human perspective to find a measurable, objective truth.
Right.
We learned that the plan organizes our horizontal movement, testing the social logic of how we flow through space. We rotated our scalpel to find the section, revealing the vertical volume, the weight of the structure, and the dramatic path of light,
And we stepped outside to examine the elevation.
presenting the composed public face that engages in a civic dialogue with the city. Together, they form an interdependent, unified system of spatial thought.
They allow architecture to be analyzed and constructed not as a subjective painting, but as a rigorous system of tectonic and experiential relationships.
For you listening, you now possess a foundational architectural literacy. The next time you look at a real estate layout for a new home, or glance at blueprints on a construction fence, or even just study the flat facades of buildings while waiting for a crosswalk, you can look at them with a highly critical, structural eye.
You understand the invisible, imaginary cuts that brought those structures into reality.
You have acquired the precise diagnostic vision of the architect.